Awesome. So hello. My name is Christopher Olekas, and I'm here today at Kitchener-Waterloo Video Tech Meetup to talk about per title optimized video on my device. But before we get into that, I wanted to talk about DMUX 2020. So DMUX is an event that been happening at least 5 years in person. They did 2 years of online meetups. This year it was held in October 12th and 13th in San Francisco. There are speakers from all over the industry. So Twitch, Warner Brothers, Discovery, Comcast, Bitmovin, Paramount, Vimeo, Akamai, Amazon, Broadpeak, SSIMWAVE, VLC, Google, Disney, Mux, Brightcove, and more. And the topics kind of centered around all sorts of different video related things. They had, talks focused on playback, where, JavaScript video players were modified to insert, different audio tracks when you were playing back, say, Harry Potter. There was a lot of talks about CDN logs and, how that can be used to help players play better and CDN serve the content better. There was talks about the history of test patterns. There's talks on RTMP, WebRTC, different ABR switching algorithms. There's some talks about synchronizing metadata and using metadata for different playback capabilities, and a couple of talks on the importance of captions. There was a talk from a group from Montevideo, Uruguay, and they have their own meetup, and they talked about a video summer camp. So if you wanted to, go down to Uruguay, hang out with this company called Qual Labs, they'll, set you up, and you can work with their team on some like hackathon projects, and just vacation in Montevideo, Uruguay, which is pretty nice. There was a couple of talks in HDR, which was a really interesting one about, which formats preserve creative intent better, and then another on color grading HDR. And there's also talks on codecs. So origins of DCT, zigzag, per title optimization, and, why are there fractional frame rates? So things that we're still dealing with in 2022. So here are just some of the photos I took. So this is Jean-Baptiste Kempf. He's one of the maintainers for VLC and FFmpeg, which I personally use a lot. So he was giving a talk about updates to FFmpeg. This is a person I work with, Hojet Yagane from SSIMWAVE, talking about sort of HDR and how PQ and HLG both have their kind of limitations when maintaining the HDR color volume. This was one of the talks from Alex Zambelli from Warner Brothers, talking about fractional frame rates and how to deal with it, how to deal with drop frames. Well, what's a SMPTE time code? Some fun stuff. This is Steve Robertson from Google. He gave his talk as if he was giving the talk 5 years from now and talking about why HDR failed. It was pretty funny. So there's, like I said, about 500 people. This is not all 500 people, but we were in this interesting meeting space where this was kind of the forum where you could go after or outside of the presentation room. And yeah, even one of the I think AWS Elemental directors, I think, is a DJ, so he DJ'd that final day. So that was really neat. So really recommend going out. There's lots of talks all over. There were online tickets as well this year, and presumably they're going to continue doing that. But the VODs for them are should be available by the end of the year. They said typically December they'll start posting them. But yeah, that's I enjoyed it. I enjoyed being back. I enjoyed talking to people, and yeah, there's lots of good talks. They have a YouTube channel if you want to go check that out. But yeah, so I guess go back to the first slide. We'll jump around a little bit. So yeah, my name is Chris Olekas. I work for a company called SSIMWAVE. I've been working in video now for over a decade. Started working at a company called Magnum Semiconductor, which did the video DSP. Learned a lot about video then. Then joined SSIMWAVE about 5 years ago and started to learn more about the application side and more of the OTT side of things, where previously at Magnum was a lot of broadcast, ASI, SDI, those types of things, just as a bit of a background. Yeah, so I want to go over some definitions to start. So what I want to first talk about is adaptive bitrate ladders. So mostly all video that we watch or consume that isn't kind of point to point like this is delivered over HLS or MPEG-dash, and they have different renditions, and these renditions consist of potentially different resolutions or codecs, but are mainly differentiated by bitrate. The term ladder is pretty familiar. It's a term to describe a set of rungs for playback where each rung is at a specific resolution and bitrate, and the adaptive part means that the player is meant to adjust which rung is used based on the network conditions. So this is primarily bandwidth, but could also include latency. And the player is trying to select this rung that will be played with minimal to no buffering. So let's go back to around 2015. This is from an Apple Tech Note 2224. And so this is a recommendation from Apple based on their HLS, their HTTP live streaming media spec. And, around 2015, these were the resolutions. See if I can I get pointers going? No, I can't. I don't know how to get the pointer going. But you can kind of see that the first column described where they thought these video renditions would be played. The second column is the dimensions. So you go anywhere from 416 by 234, you get 640 by 360, 1280 by 720, and 1920 by 1080, and get the various frame rates. And then you can kind of see, the bit rates span from 200 kilobits per second all the way up to 8.5 megabits per second. And so I don't really know at the time. I wasn't really focused too much on this. I know at Magnum we did encoders that we're looking to do kind of the broadcast version of this ABR, and I think at the time it was called mobile handheld. But yeah, this was basically fixed, and a lot of the video was being produced or produced for consumption at these resolutions and bit rates. So then Netflix came around, and they've been around for a while, and they produced this blog called Per Title Encode Optimization. They basically said this ladder was insufficient. That's going to underperform for some content, overperform for others. And when per title optimization is applied, what's going to happen is that under bitrate constrained environments, the best quality is always provided. And when bitrate is not constrained, the best quality is provided at the lowest possible bitrate. So this obviously has benefits. It's cheaper to transmit, cheaper to store. So it doesn't cost money to host your streaming service. again, this is part of that blog. They took 100 assets, they encoded them using quantization point rate control in X264. The graph is, anyone who's pretty much dealt with video has seen a graph like this, where it's bitrate along the x-axis, quality on the y-axis, and they use scaled PSNR, where they scale the output resolution to match the input resolution. And you can kind of see there's, in the top left quadrant, you have, I would say easy content, where you get kind of high quality at low bit rates. And then in the bottom right, you have really hard content that this turquoise or cyan one asset, it's up to 25 megabits per second, and it has a scaled PSNR of around 38, where 38 is acceptable, but anything sort of 45 or over is considered high or good quality. So there's been like a bunch of reviews since this was 7 years ago. There's been a bunch of reviews on this blog post, and people have reached out to the original authors, and have said, "Oh, why wouldn't you use something else other than QP encoding? Why not CRF?" And the authors have pretty much said, this basically fits if you choose any sort of content-aware encoding parameter and any sort of quality parameter. So generally, this fits for any content, because content's gonna vary. So continuing on with the blog post, there's a few diagrams they showed. So this is them comparing, their pair title, which is in the blue, with the standard fixed bit rate, which is in the red for simple content. And you can kind of see that when the parameters are tuned, you can get a really good quality encode at encode A, where encodes B and C are wasted, and it's not really providing much in terms of improved quality when you compare it to like the 46 PSNR that A is at. And then additionally, you kind of see at 720p that D encode, it's way wasted compared to the equivalent per title bitrate encoded ladder. You're saving like almost 2 megabits to provide about the same quality. Another one where they said this is hard content, and again, this is where I started to see when I was thinking about what I wanted to talk about for this talk, is that you see that they're leveraging transition and resolution. So they're going from this 1080p to the 720p to the 720p at B and C for the top 3 rungs in the profile, compared to the fixed bit rate where it was 1080p. So this content was so complex that encoding it at 1080p at this fixed bit rate was insufficient to provide the quality required. So by changing the resolution from 1080p to 720p, you kind of get you get the quality for free, because you're using the same amount of bits to encode a smaller resolution. So that encode is going to get better. And then, the big thing coming out of all of this was convex hull. So the convex hull is basically a conjunction of the 3 bitrate quality relationships at the different resolutions. So you have your high resolution, your mid resolution, low resolution, and the optimal delivery would be points on this convex hull. So each resolution has a bitrate region in which it outperformed other resolutions. So basically everything after this point, the high resolution does better. Everything after I don't know if you see my mouse, but everything after halfway up the low resolution, you end up seeing that the mid-resolution outperforms it, and then the high resolution afterwards. So this is, Pareto efficiency is what they talk about, where no individual or preference criterion can be made better without making at least one individual or preference criterion worse. So, and then they end up sort of defining per title optimization as, discovering what this convex hull, what these resolutions and bit rates are going to be. So another thing that, in addition to this, is you need content-aware encoding. So I feel like per title optimization and content-aware encoding kind of go hand in hand. Some people call them the same. To me, I would say, per title optimization is an entire ladder, but you could have content-aware encoding for an individual rung on that ladder, where you have an encoder and you give it some quality-based parameter. So it's not necessarily bitrate driven. You say you give it a QP, which is more for it's in libx264. It's in a lot of the open source encoders. Or you give it, if you have an elemental, they've done QVBR, which is the quality variable bit rate. So you give that value from 0 to 10, and based on bit rate and resolution, it's going to provide sort of a constant quality encode that they're going to try to reach at that QVBR level. Similarly, CRF, it's constant rate factor. It's in libx264, libx265, libvpx. I know bitmovin uses it as part of their per title optimization. But yeah, you give these parameters to the encoder, and the hope is that the encoder is going to encode an asset at the best quality possible. They do this with some pre-processing done within the encoder loop to determine, the content complexity. Harder video, it's going to give more bits up to the bitrate limit. Easier video, it's going to go less bits to meet the quality parameter provided. You can kind of, I don't remember if many encoders kind of allow you to adjust this on the fly. You kind of have to give it prior to your encode. And a lot of vendors kind of differentiate themselves with the pre-processing and guessing of what these parameters are. So I think every encoder vendor right now says, we're going to give you per title optimized encode, and a lot of the times, and you just have to see how they perform. But the last thing I wanted to talk about from that blog article was devices. So at the very end, they said, with per title optimization, it's going to give you the best recipe for your devices. And I was thinking about this and going back to that 1080p to 720p transition in that hard content slide. I wanted to look at what were the devices 7 years ago? What were the resolutions? So the iPad Pro and iPad Mini, they both had fairly large resolutions. So if you had a big ABR ladder, it would play on those iPads. But the Amazon Fire tablet, apparently it was a lower resolution. It was really weird. I don't even think it was actually HD. So if you're going to be playing your content on a Fire tablet, it didn't make sense to serve the 1080p and 720p renditions. So I started to dig into it more, and you had these premium tablets come out. So the Xperia Z2, Nexus 9, NVIDIA Shield tablet, iPad Air, and all of these, they they could probably play 1080p. So it was important to have 1080p in your 2015 ABR ladder. Then you have your value tablets. So the tier below. Everything except for the Yoga Tablet 10 HD Plus was pretty much only going to be playing 720p. So why would you kind of do your ABR ladder if, depending on what device it was going to be played on? I wanted to do this for 2020, and some interesting numbers. There was 13 phones that had a 720p resolution that were released in 2020. So that's probably like 1% of like video being watched on those phones, but it's still kind of interesting that even in 2020 we had some 720p phones. There's 22 tablets that had a 1080p resolution released since 2020, so that's a little bit more. Again, and I think for anyone who's like has a large catalog, they still have to deal with devices from 2015. But even in 2020, there's devices that can't have 4K. So if you wanted to put 4K in your ladder, that's considerations. There's 36 tablets with QHD resolution or greater since 2020. So that's a consideration. There's two outliers I found. A Lenovo Tab M7 had a 1024 by 600 resolution, and that was released in June 2021. So I just got a Pixel 7 Pro, and that's close to about the same size as the M7, and it has like a quarter of the resolution. And then finally, there's a Yes Epic 3 tablet that has a 1024 by 600 resolution, and that got released May this year. So low resolution devices still out there. So with that being said, I want to go back to convex hull. So you have your high resolution, your mid resolution, your low resolution. You have all the devices we were talking about. So what if we mapped those resolutions to the devices that they're going to be played on? So OLED, 65-inch C9 TV, a laptop, and a phone. So I was thinking about this because at DMUX, there was a talk by Will Law, who is a chief architect at Akamai, and he was talking about CMCD, which is a protocol used by or wanting to be used between players and CDNs to kind of optimize CDN load balancing, I guess. Probably not a good description, but one of the slides that he shared, which was actually extremely interesting, was that out of he monitored 2-hour period in Chicago, and he found that most playback sessions never switched, and so I think it shows 157 about 158,000 sessions were measured, and I think 10% of sessions contain all the switches, and the worst 1% contain 2/3 of all the switches. So like 90% of the time, a session didn't switch. So with that being said, how can we leverage this basically? So continued to look at sort of this experiment I was building up. Use Tears of Steel. Tears of Steel is a sort of open source live action with some computer graphics content that you're able to sort of download and use. I used Simplest VQ Dial, which is a product SSIMWAVE sells, and it allows you to kind of, given a target device, encoder performance score, which is a score from 0 to 100 that describes or measures the amount of amount of details and how well preserved the original is from the encoded output. So, you know, anywhere above 80 is good. Anywhere above 90 is really good. 70 is about where it starts. You start to get really, you know, annoying artifacts in the output. And you also give it the resolution and you give it the max bitrate. So I took VQ dial. I gave it a few target devices, an OLED LG C9, a MacBook Pro, and an iPhone X. I took the encoded performance scores of 70, 80, and 90. And I took resolutions of 1080p, 720p, and 480p. And I used HEVC. I set a 10 megabit max bit rate with a 2-second BBV. So if we go back, our resolution for the phone was the 720p, or the 480p. The resolution for the laptop is the 720p, and the resolution for the OLED is 1080p. So this is what we kind of get. So it's not kind of the best convex hull. So this is I would get 27 encodes, but this is basically, you know, the three that I kind of mentioned before. So you can kind of see, you know, with the OLED 65-inch C9, you had 3 different encoder, or 3 different EPSs at 3 different bit rates, and then you kind of see the MacBook Pro at 85, an 80, a 69, and the 3 different bit rates. And this is basically the data. And so you can, if I just, you know, kind of map a convex hull line onto it, you know, I get kind of, this is my, you know, per title optimized, very, very quick ad hoc experiment where I kind of, you know, this is the best quality that we could deliver if we encode each asset independently. So you go from 88 and 84 to a 79 to 76 to a 67, and that they go into a little bit more detail, and then as you read more into the science, that, you know, there's just noticeable differences, and there's a lot of science with respect to how big of a jump there is between the different bit rates and the resolution. So what if we can get constant quality? So how do we do that? Well, I did it. And this was using the encoded performance score. So one thing that the Sim Plus encoded performance score is able to do is it's able to do a device adaptive score. So when we go back and looked at, try to find that slide. Is it this one? No. The content problem. So this as QP and being content aware, if using scaled PSNR for this quality variable here doesn't take into account what device it's going to be played on. And that's one of the benefits that Sim Plus can have, and that the Sim Plus EPS score is actually able to do it as a device adaptive. So it's taking this 1080p resolution, 2.6 megabit encoded asset, and it's providing an EPS score as if it was going to be displayed on a MacBook Pro. And if my intention is that, you know, if I only had 3 rungs in this ladder, presumably I'd try to play this top profile if I was playing it on my TV, this middle profile, the MacBook Pro profile, if I was going to play it on my laptop, and if I was going to be playing it on my iPhone X, I'd be playing the 720p, and there we go. Going back, we kind of get our constant quality encode, because it's leveraging the fact that, you know, we're beneficial enough to live where, you know, high bandwidth internet is fairly ubiquitous, and you know, these bit rates are not, you know, crazy. So it's really going to be based on the device capabilities that's going to be limiting the content that we're going to be watching. So, you know, what if you know that this 88, 89 is too high, and we want to have a second ladder? We want to look at, you know, constant quality of 80. Can kind of do the same thing. So with this, again, took, you know, a high profile 1080p 1.23 megabit encode. It ends up having an encoded performance score of 80. The MacBook Pro is, when you take the 1.13 encoded bit rate and play it on a MacBook Pro, it ends up with an 80. The 0.99, we drop the resolution. We're still able to maintain an 80. And that's 720p at 700 kilobits per second. We're still able to maintain an 80. So, great, we did it. We made a constant quality encoder. Summary. So, you know, fixed bit rate ladders are not sufficient, as the ladder will underperform for some content and overperform for others. This is essentially the gist of the per title optimization work that Netflix kind of pioneered. Per title optimization by context-aware encoder, when the asset is played under bitrate constrained environments, will always provide the best quality if the metric for context-aware encoding is good. And per title optimization by context-aware encoder, when the asset is played without bitrate constraints, will always provide the best quality at the lowest possible bitrate savings, at the lowest possible bitrate, saving transmission and storage costs. And you know, that's good for all of us in the bottom line. So that's it. Then oh yeah, thanks everyone. Yeah, thanks for listening, bearing with me.